Thanks very much for the introduction, and hello everyone. My name is Villedieu. I'm one of the co-founders of Linkers. Linkers is a company that provides graph visualization and analysis software. And today I'm joined by Alan.
Thanks, Sean. Hi there, my name's Alan Brown. I'm the CTO of Aptitude Global. Aptitude are a data and AI consultancy. We're based here in the UK and in Spain.
So let's get started. So we are going to talk first about ESG risks. So ESG stands for environmental, social, and governance. It comes from finance, and as a lot of things from finance, it has somewhat of a bad reputation, with the perception that ESG is more about cosmetics than substance. Specifically, a lot of organizations that are investing in ESG have a narrative around which their investments are more about the perception of the public versus real change. But the point I want to make is that we are not going to talk about ESG finance today. We are going to talk about ESG risks, and these risks are very much real. In the last month alone, there's been, for example, a flood in the Valencia region in Spain that caused more than 200 deaths, and a hurricane in Florida that caused upward of $85 billion in damages. So putting ESG risks in perspective, it's important to note that in 2023, more than $25 trillion were invested in ESG. It's also estimated that without changes, by the 2050s, the cost of climate change could represent up to 20% per annum of the value of the real assets held by the global Standard & Poor's 1,200. And finally, ESG risks are oftentimes cited as the number 2 risks for executives. And these risks, they're only going to increase. For example, there are 2 recent pieces of legislation, the German Supply Chain Due Diligence Act and a European directive that put the burden of regulating human rights and climate objectives on the shoulders of companies. So there are growing social and political pressure on those companies around ESG risks. And it's a problem across virtually all sectors and any industries. For example, in national security, it's important to protect key companies and identify whether these companies are relying on minerals, on companies that are controlled by foreign adverse states. In manufacturing, it can be important to identify within the supply chain of a given company if there's exposure to natural disasters. In terms of compliance, it can be the same logic, except here that the risks are more related to forced labor, sanctions, that sort of things. And then in finance, ESG risks can look like can be rated to the ability can impact the ability to underwrite risks in insurance, and it can also be important in capital markets to identify opportunities to long and short specific stocks based on their exposure to ESG risks. And tackling these risks is really changing from a data perspective because it requires certain internal data, such as data about clients, suppliers, locations, products, and parts. But it also requires external data about ESG ratings, data about sanctions, company ownership, supply chain, climate events, and more. And it's not just that you need to have this internal data, that external data. It's also very important to understand the connections. Going back to our example of forced labor, so you want to understand your suppliers, but also maybe augment your understanding of your suppliers with some external data about suppliers. And beyond that, you need information about what suppliers are exposed to forced labor. So it's a real challenging data problem. And we can illustrate all of that via a very simple example. Here we have a company on the left. It's connected to a supplier. Maybe these two organizations are based in the same region. So if we are only looking at one level of relationship, maybe only looking at internal data, this data that we are currently looking at, we may think that if that region is not exposed to any climate risks, then the company is not exposed to climate risks, period. Except that if we go further, we may uncover using external data that this supplier relies on another supplier, that first green node, that this supplier relies in turn on two other suppliers, and maybe these two suppliers using yet another data source. Maybe I can find out they are actually in a zone, in an area that's exposed to climate risks. And then all of a sudden, it really changes my perception of the risk of the starting point, because if I understand these indirect connections, I can understand that there's some indirect exposure to climate risks, and then the risk of my company it just increases. So that's the sort of insights that can be uncovered. But the question here is how to do that at scale. We're going to demonstrate that, and we will do that by combining graph analytics, entity resolution, and third-party data to tackle ESG risks. So we have prepared an ESG demo. During that demo, we'll show data integration, the use of graph analytics to spot ESG risks, and also concrete use cases, such as investigating a particular supply chain. For the demo, we are going to use a combination of dummy supply chain data that's anonymized, and also data coming from Dun & Bradstreet about ESG risks, and that data will be anonymized. The data itself, it will be stored in Neo4j, and we are going to be using Cypher to risk score the data, and we will analyze the results using linkers on price. And with that, over to you, Alan.
Thank you, Jean. If you can cancel the screen share, then I can enable mine. Excellent. Okay. Seamless transition. Okay, thanks, Sean. So before going into the demonstration, I just want to talk through the end-to-end process of building the knowledge graph for analysing the ESG risks, and the process in terms of how we actually, how we bring the data in, how we resolve the data, how we score the data, and then how we analyse the data. So starting with the first challenge, data acquisition. Every company, when analysing their ESG risk, their ESG profile, will have access to their own internal data, obviously. So that'll be information about their clients and potentially their immediate, well, definitely their immediate tier one suppliers, so who their immediate suppliers are. But how do they go beyond that layer of suppliers into the next layer, so tier 2, tier 3, tier 4? That requires third-party data. Okay, so there's a definite requirement there that we need to integrate data sources, additional data sources, to augment the data that we store internally. And that data can be vessel data, company registrations, Exhibit 21s. There's quite a significant amount of data available. So our approach for this demo today, we're going to be working with Dun & Bradstreet data. So Dun & Bradstreet have very unique proprietary data on supply chain. So they've got 627 million business-to-business naval shipments captured per year. The one we're specifically going to look at today is climate risk data, which is very relevant based on the example that Jean shared earlier on risks around flood, wildfire, drought, heat, cold. And this tracked against different time horizons and specific locations globally. And also business ownership data and data about other ESG risks. We're not going to cover those today, but Dun & Bradstreet have a very comprehensive data set, and we'll show an obfuscated example of this in the demonstration. So first step, you have to integrate that third-party data. That creates some significant challenges. We've all been there, having to handle both structured and unstructured data, data from databases, APIs, streams, news reports, contracts, forms, These can often be very large data sets, particularly if you're dealing with third-party data sources and you have to load the entire data set. That can potentially be hundreds of millions of records, so you need something that scales. That data can have significant variations in data quality, data completeness, and you have to be able to handle both temporal and geospatial data when you're dealing with graph analytics and ESG risks. So our approach in the demo and our approach more generally, we use Databricks for that data processing layer. It has distributed compute capability, which means we can scale to dealing with very large volumes of data. It supports both batch and real-time processing. It's a very simple way of integrating data quality frameworks. I talked about the requirement to standardize the data and to clean the data. It has been built strong data governance support, feature engineering, machine learning support. So we've got a fully comprehensive end-to-end data capability in our data processing layer. We do need to perform entity resolution on the data first. I will cover this in the next section. And for loading the data into the graph, we'll be using Neo4j's Databricks connector. Again, I'll give a demonstration of that in the demo. Our schema is quite simple. I'll give a demo of this as well, but we're effectively connecting companies together with ownership of supplier relationships and then augmenting the climate risks. I mentioned entity resolution as being a very important part of the end-to-end process. If you need to integrate third-party data with your internal data, that data often appears differently across those data sources. So for example, the same company might have a different name, might use a different abbreviation. We need to be able to link these and confidently say that the entity in data source 1 is the same real-world entity as the entity in data source 2. Boeing Inc. is the same as Boeing France. That's easy if you have a unique ID, but what if you don't? What if you're relying on matching on names, addresses, company registration numbers, the directors and shareholders, etc., email addresses, telephone numbers? We need to build an entity resolution process that allows us to link this data. Building it's hard. It's very, very hard. We've been there many times. We've done that many times. What we use, and we're going to demonstrate today, is using Senzing's entity resolution engine in order to be able to identify the duplicates, but also crucially build the links between our internal and third-party data. Senzing real-time capable, very scalable, works out of the box with very little configuration, has AI built in to enrich its entity resolution capabilities. We'll use this to create a new node in the graph. It's called an entity organization. We'll create some new relationship types that show the different types of linkages between our internal and third-party data. They'll be resolved to, which means the same, possibly the same as, which means they're possibly the same as, and possibly related to, and you get the picture in terms of what those mean. So they'll be added to the source data in order to show how it's connected together. Next step, we need to perform risk scoring. Off-the-shelf ESG tools will provide ESG risk scoring for you, but these risks change frequently, and so does your data, and so does the available data sets. So how do you remain agile? Agility requires the ability to ingest new data sources quickly, conform that into your own model, identify and model new risks, so the ability to create those new risk scoring models and be able to modify your existing models if they're no longer performing. The difficulty when you deal with off-the-shelf ESG tools is you don't have that flexibility. Risk scoring is relevant to not just the risk associated with the company itself or the supplier, but also the wider supply chain. And again, that's not something that's often provided by off-the-shelf ESG tools, being able to perform network-based risk analysis. So our approach, we'll be using Databricks. Again, this is a scalable analytics environment, combination of Neo4j's graph data science and Databricks for Neo4j's GDS for using graph algorithms, so running graph algorithms across the graph, and for computing risk scores. We're going to use Linkurious Enterprise to be able to execute graph queries at regular intervals, and also to enrich the graph with new properties, which we can then use to analyze and determine additional risks. Linkurious Enterprise will also be used to schedule a scoring process, which again I'll be able to demonstrate as part of the demonstration. Finally, you need to be able to analyze your graph. So how do you create notifications based on a new emerging risk? So for example, a weather forecast for an imminent flood in a particular area. You need to be able to monitor that and alert on a scheduled basis, almost in real time. but also you need to be able to give access to the data, the graph data, to non-technical users. And again, this is why we're using Linkurious Enterprise in order to raise alerts for risky companies and provide analysts with that comfortable interface that they can use to interrogate the graph without having that direct graph skills. So just a quick overview of the architecture. The data flows left to right. This is deployed on Azure, so what you're going to see today is deployed on Microsoft Azure. We bring the data into our cloud storage. We process it using Databricks into a bronze layer. We have a stream processing engine, which is taking the entities and taking them through the entity resolution process and augmenting the silver layer. The silver layer contains our conformed data. This is data that will look like the nodes in the graph and the relationships in the graph, standardized so that all of our data sets have a similar structure. We can then load that into the graph using the Databricks connector into Neo4j, where we've also got Neo4j GDS running. We can then run GDS to the graph data science algorithms to enrich the graph further, or to bring that data back into Databricks for further augmentation of our risk scoring models, etc. Finally, on the right-hand side, you'll see Linkurious. That's connected to Neo4j for visualization, alerting, and investigation, and that's the user interface. We'll also be allowing users to directly query the underlying graph using Linkurious. Okay, so the demo, jumping straight in. Let's assume for the next 10 minutes that we are an industrial company. We want to analyze the risk in our supply chain. We're going to process the data using Databricks. We'll merge a fictitious internal data source with some obfuscated Dun & Bradstreet data for climate risks. We'll show you how you can leverage graph analytics to identify those risks and how you can provide the analysts with the access to be able to access those risks and results. Okay, so jumping across now to Linkurious. This will be the first time you've seen Linkurious interface. So in order to get you familiar with the data model, I'm going to go in and create a visualization. So this is creating a new investigation. So I will search for a node called ScotMed. ScotMed is a supermarket in the UK. This is our internal company data. So you can see here data source is CRM. If I double click this, it's going to show me the tier 1 suppliers that I have. Now these are also from our internal data source CRM. Now, I could manually navigate this graph and try and identify risks. It would take me a while. So I'll double click this one. I can double click this one. This could be quite a painful and slow process. Or I can use some of the Linkurious features to quickly augment and identify risks within the network. So here's a pre-prepared query that I have created called Find Climate Risks. So this is very simple. It takes the company record and navigates a number of hops until it finds a climate risk, and we can specify the depth of that up to 10 hops, and it's going to return that risk. So let me just show you this in practice. We run a query, find climate risks. I'm going to set this to 8 hops. I'm going to run this, and voila, we're able to show how we get from our internal data, which is the ScotMed company, through the internal tier 1 supplier. Now this green node is our entity resolution node. This is the entity resolution process that's linked together our internal data and our third-party data. So we're now hopping into the Dun & Bradstreet data here. So you can see here the data source has changed to Dun & Bradstreet. So we've got has supplier, so Tunnux, who make caramel wafers and snowballs, for those that are aware. Have a supplier of AG Plastics, who has a supplier, the baked potato company. You can tell this is not real data, who have a site in Edinburgh, who have a location, and again this site has been linked to the location of the climate risk, and these climate risks are attached to the location. So again, very easy for us to navigate this. I'm just going to draw your attention to the entity resolution process. Here we've got Tunnux Limited. This is a node called Entity Organization. We created this based on the Sensing entity resolution process. And what it's saying to us here is that this record is resolved to this record and this record. So saying these two are the same. So I just want to validate that. So we've got a plugin which we've developed on top of Linkurious that queries directly the Sensing API for these two entities, and we can just click compare and we can look at the data points that we passed into Sensing in order to compare them. So we've got the name, slight variation, doesn't matter, it's still 99%, it will discard things like limited. The address, I've got the Spanish version of Edinburgh in here, Edinburgh. Again, that was just ignored completely and is 100% match. So that's great. So that's a valid match, and we can see clearly that this is the relevant node. So that's how you perform a manual investigation and how you would simplify the process of conducting that investigation using query templates. I'm going to come back to the dashboard now and move on to the next stage of the demo. So how could we more automate the process of identifying alerts? So identifying risks within our supply chain. So for this, I've actually created some alerts. Alerts in Linkurious are scheduled Cypher queries that are executed at a regular interval against the database. The data, the results are brought back into a case, and the case can then be investigated by the user within the sort of the case management workflow. So I've created one here called high aggregate risk. Right. So what are we looking for here? We're going to calculate a risk in our supply chain where there's a high aggregated value of climate risk for a particular supply chain based on the company. So let me talk you through the cipher for this. It looks complicated. It's actually not that complicated. The entity resolution process makes the path longer between company and climate risk. But what we're looking for here is that companies have suppliers, and those suppliers, ignore the next part, which is the entity resolution process, have sites. So within 10 hops, we'll have a site, and that site has a location. And locations have a risk, optionally have a risk, which has a climate risk. Right? So what we're looking for is climate risks that are linked to companies within 10 hops of the supplier relationship. The reason it's optional is that some companies will not have any climate risks, and I want to calculate a zero risk for those. So that's why we've got the optional match on the last the last node and the last relationship in the path. And then what I'm doing here is just calculating the aggregation of the current risk. Current risk in the Dun & Bradstreet data, and I'll show you what this looks like, is basically an immediate forecast for either like a wildfire or a precipitation or a flood, for example. So we're just calculating the current risk linked to any company through the supply chain. Now, this is implemented as a pre-processing step. This is a new feature of Linkurious. It's been released in the latest version. This will be scheduled to run before the alert itself. So this will run the pre-processing step. Then the alert itself will run. The alert itself is quite simple. It's going to look at that aggregated risk attribute that we've just stored on the company node and say if it's greater than 15, create a case for this particular company. And in the results, we're going to expand out the graph here. We're just using an epoch procedure here, spanning tree, in order to navigate the relationship filter up to 10 hops so we can see the full path. Now, when I run this, again, this is quite a simple query. Let me just have a look at the case that was created. So we've got ScotMid again, which is the example that I just walked you through. It's got an aggregated risk score of 21. So when I open this, if I just zoom out a little bit, I can see ScotMid, and if I just select all of the nodes in here, you can see the climate risks are highlighted on the left-hand side. I could scroll along here to the actual climate current risk. Current risk, if I add these all up, it should add up to 21. So you can see 1, 3, 5, etc., etc. And then we get to 21, which is the cumulative risk score for ScotMid through its supply chain to all the climate risks. So that's an example of how we could create a new attribute from Linkurious, store it on the node, and identify a potential aggregated risk within the network. I'm going to just drop into Databricks now and just give you just a little example of how we load the data. I'm conscious I've not got a huge amount of time, so let me just quickly show you the next alert. This is the process for loading to Neo4j. Again, this is using the Databricks connector. So here we are, very simple. We connect to Neo4j. We build the we populate the nodes and then relationships, and there you go, it's just examples there. But I am going to just show you how we can create some new properties and use graph data science. So here we go, data science folder. The first thing we're going to do is create a risky supplier node label. So here we go, we're adding this. So where the current risk is greater than 3 in a supplier that has a climate risk, we're going to create a risky supplier label. We then create a graph projection of risky suppliers, and then we're going to run a weakly connected components algorithm just to write back to the graph the component ID. So what we're doing here is basically looking at the graph, creating subgraphs of all of the supply chains, giving them a component ID, and then we can come back into Linkurious here and query to try and identify the nodes in the graph that have a risky, a high risk ratio. So again, if I just quickly show you the query here, we've got this query here. We were using the risky supplier label that we just created. So we're getting suppliers, grouping by the component ID that we just created. So there's one component ID per subgraph per supply chain. We're getting all the suppliers in that graph. Then when they've got a risky supplier label, i.e. they've got a current risk greater than 3, then we add them as a risky supplier, otherwise they're not a risky supplier. And then we calculate the ratio of them and find those that have a ratio of greater than 10% of risky suppliers. So I'm going to run this quickly before we finish up. And you can see here, we've got 68 suppliers, 13 risky, 55 normal. If I open this, that's the full supply chain there. We've got 4 companies in there. It's not very easy at the moment to see where the 13 risky suppliers are. So I'm going to open this in the workspace. I'm going to just tweak the filter so I can see these risky suppliers more clearly. Increase this to 300%. They should all pop up now, and I can see those 13 risky suppliers that all are that are connected to climate risk at particular locations within our supply chain. Okay, that's everything I've got to show you today. I think it'd be good to take a couple of minutes of questions. Thank you everybody for joining today, and please do reach out and connect directly afterwards to either myself or Jean if we don't get time to answer your questions in the next couple of minutes.